everyone, today I'll be talking about quadratic functions. I'll start off by talking about standard form and general form. Standard form is f of x equals a, parenthesis, x minus h, parenthesis squared plus k. And the general form is f of x equals ax squared plus bx plus c. For those of you who forgot how to graph quadratic functions, there are actually two ways for graphing. One is by using transformations. The second is using other information about the quadratic. For instance, if a is greater than 0, it will be a positive graph. If a is less than 0, it will be a negative graph. Other methods you could also use is finding the vertex, finding the x and y intercepts, and the axis symmetry. You might be thinking to yourself, when can or when are quadratic functions be used in real life situations? Well, if you throw a ball, it will go up into the air, slowing down as it goes, then coming down again. A quadratic equation will be able to tell you where it will be. An example I have today is find the vertex, intercept, axis of symmetry in the graph, and then the graph. Y equals x squared plus 8x plus 13. I did first find the vertex, which was -4, and I plugged the -4 into the x of this equation, and I got -3 as my answer right here. And so the vertex was -4, -3. Afterwards, I found the axis of symmetry by using the same formula as the vertex, which my answer was -4. The third thing I did was find the intercepts by using the quadratic formula, which a equals 1, b equals 8, c equals 13. Once I did the calculations, my answer was -4 plus or minus square root of 3. Next thing I did was determine if the function is concave up or concave down. And since the coefficient is a positive, it will be a concave up. I did say I was going to graph the equation, but I just went ahead and determined whether it was concave up or concave down. Another example I have is an application problem, which is a rancher plans to use 1,200 feet of fencing in the side of his barn to form a rectangular boundary for cattle. What is the maximum area? I did draw my little picture, and this part is enclosed. So I start off by writing down 2 width plus 1 length equals 1,200, because there's 2 width and 1 length. And so the length equals 1,200 minus 2w. I will be using this equation later on in a problem. Afterwards, I move on to the area which equals a equals length times width. And I use this and plug it into the L, which is 1,200 minus 2w times w. So it would be 1,200w minus 2w squared, which a equals -2w squared plus 1,200w. Now I use the vertex formula, which is -b over 2a, which in this case, -b is 1,200, and a is -2. After I did the calculations, the width was 300. And I did plug it back into the w up here of the 2w, which was L equals 1,200 minus 2 times 300, and the length equals 600. To find the area, I did 600 times 300, which I got this answer. And yeah, that is pretty much it. I did get all of my sources from our math book and some of my notes. And that's pretty much it. Thanks for watching, guys.